Microphone muted again. At some point I will learn it. Thanks so much for the sub. For the sub Bcam. So, today will be a shorter stream. As mentioned yesterday, I go out later tonight to a meetup, and so I don't have too much time. That's why also the stream is earlier in the day. I planned roughly 2 hours, but I can't do longer because I have to get ready to go out and stuff like that. So today there will be a limit on the stream length. Yeah, how's everybody doing? Thanks for stopping by to the stream. Yeah. So let's see. Let me show you where we left off yesterday. There we go. So this here is the module that we built yesterday. This is the first register module of our 8-bit computer. We haven't quite finished it. We need to do the LEDs here, and so that's kind of the plan for the stream here, to do the LEDs, and maybe we watch the next video as well. And I think, okay, so a super nice person on my Patreon has messaged me a list with all the videos of this series by Ben Eder of building this, commented what is like coming up next without like spoilering, just to give me like an idea of what I have to do for the streams, something like this. So that was unexpected and amazing. And so in there it said that a couple of these register elements are built in the background, and so of the series that will be coming up. So I know that we will make a few of these starting, I guess, today in the stream, and then maybe the next 1 or 2 streams just building a couple of these. I think there were like 4 overall or something like that, but let's see. Right. And here's the clock module. Okay, any questions so far? Everybody caught up? First time on the stream, or should I just get started on building it? Oh, there's one other thing. Okay, before we get started. So as you can see, there are a lot of wires that we had to cut. And so I have an announcement for you. Let me change back to this camera here. Okay, wait. Everybody, pay attention. I have an announcement to make. Something incredible happened today. I was being let down by the delivery of tools that we need for the battle of the wires. So today, before the stream, I ventured out into the world, into the real world outside. I had to encounter people, other humans. I traveled in a carriage full of other humans. It was awful. I walked through the blazing sun to find the one tool that we need after being let down by the delivery people. But I couldn't wait any longer. So, here it is. A wire stripper. Finally, we can ditch the terrible clipper to strip the wires and destroy them. We have a wire stripper. This is gonna be amazing. Oh my gosh, I can't believe that I finally got it. I don't know if it is any good. It's not the one that I wanted to order online, but I think it will help us tremendously with the task that is ahead of the dozens and dozens of wires that we need to strip. I'm so happy. Just to do the important thing, this was music by Alexander Nakarada, but Creative Commons with attribution license. So here's the attribution. Oh, god damn it. I'm so happy. I keep having to add stripper to the auto moderator because the auto moderator keeps deleting all the messages with stripper in it. But it is stupid. So it's like if somebody ends their sentence with like a dot, then it's like stripper dot. That's the sentence that's being censored. And just whitelisting stripper doesn't take care of that. So I need to whitelist stripper dot and stripper comma. And then people had like spelling mistakes. So it was stripper comma dot and stuff like that. Finally, a wire stripper. So let's see how this goes. Trash can, and I need to put my light back where it belongs. Bad regex. Yeah. Okay. So let's try out this wire stripper. Let's see if it does the job that we need it to do. I tested it just briefly in the store. I brought a spool of wire with me to the store and then I tried it. So let's see. Okay, yeah. The focus will probably screw us over. But let's see. There it is. What an amazing tool of engineering. And the wire doesn't, the core doesn't look damaged. So that seems fine. Whew. Magnificent. That's a great word. All right, okay, so let's add here the LEDs. We need red LEDs for that. Let's see. Stripping on Twitch. You know, I keep getting whitelisting the term stripping, and then at some point we will actually get banned because now all the variations of stripping are whitelisted. Okay, so here we have red LEDs. We need resistors for it as well. Let's see what kind of resistors do we have here. It must be a pack with a lot of them. Oh, these are huge resistors. I think I bought kind of the wrong ones. Like these are for probably way higher voltages. They are like massive. I might need to reorder those. See, these ones are smaller. These will be way too large for, like it will look hideous on the breadboard. I might use just the one in the, where's my trusted box of, I just use, I guess, these here. You just couldn't resist buying them, could you? What do you mean? Buying what? The strippers? Oh crap, I only have 3 left of the 220. Oh, you couldn't. No, I get it. I was paying it. I didn't focus on the word resist. Let's see. Wait. Okay, let's have a look at these here again. I still have more resistors over there, so I can check those as well. So what are these resistors here? What color do they have? Oh, that might be the 470. Let's see. Gold is on this side. So, crap, what color is this? Brown, maybe? 1 brown black, 1 0. No, black doesn't make sense as second. No, it's brown black. Wait, how do I read this again? I thought I know how to read this. Or is this just a weird table? Brown, black, green. Brown, black, 1 0. No, wait. Green, 120 ohm. Yeah, let's measure with a multimeter. I thought I know how to read this thing. I'm a bit confused. I blame the heat. Let's blame the heat. Oh, it's so warm. Oh, it's a 1 meg. Wait, what color is 1 meg? Oh, is that a blue? That's not a blue. That's no, in no way is that a blue. Well, okay. Right. This is the slot here for 1, 2, 3 for the 1 meg. I just looked weird. Looked at the wrong thing. Oh, there they are. Okay, so let's quickly check the other resistors that I have. I really like my new headphones. Now I have this long cable and I can like move around without having to put them off. Okay, I have like these kind of rolls that I bought at some point. I probably bought them for LEDs, so they... what headphones did you get? Those are the Sennheiser 660S. You have a preference for wireless currently? Oh yeah, wireless would also be nice, I guess. So here's something I learned recently. I didn't know like the difference between like open back headphones and normal headphones and all that stuff. I never realized that there's like a difference or that there are like preferences or for different usage things. So I kept buying these terrible headsets or headphones or something like this. And then I stumbled over this concept of open back or whatever it's called headphones. And I decided to, a lot of people seem to like them. Let's buy a pair. And my mind is blown. They are so much more comfortable because they are open, so I can hear everything around me, like these cables clashing against the table, the clicking of my keyboard. I can hear everything, but I still have like headphones on and can hear whatever is on the computer sound. So I feel a lot less claustrophobic, or it feels like a lot more relaxed and stuff like this. I don't know. I had like this whole epiphany about headphones, and I'm such a huge fan of them now. This is 110. $150. 400. Let me quickly check. Let's use these like calculator thingies. Open back so got the nice normal hot ears. Yeah, right. That's another thing, that like the air gets to it, so it's not as sweaty and stuff like this. And you know, I have noise cancellation headphones as well. Like I love to go outside with the noise cancellation headphones because I can drown out just the noise of the city, and I hate people, so it's like super nice. But for inside, when I'm here in my space and I want to hear my keyboard and maybe the dog is coming in and stuff like that, yeah. Yeah, noise cancellation is also awesome when you don't want to get distracted. For example, if I would work at an office with other people around me, then probably I would also wear the noise cancellation headphones. But my noise cancellation headphones also slowly get destroyed. I wear them so much. One of my best tech purchases ever, but look at that. That just happened like in the past few days. Okay, so wait, LED resistor calculator. Voltage source is 5 volts. Voltage drop from LED. Let's see, I need to look up the LEDs I bought. RD 13500. Zero 28. And then let's see. Maybe it's here. 30 MA. But what's the voltage? Is that Sperrspannung? I'm not sure if that's the correct one. Shouldn't it be like 2 point something? 2.5. Max is 2.5 and 30 MA. So we have 30 MA, 2.5. If that would drop to 2, then we have 100 ohm. Okay, I can run this with 100 ohm. Okay, yeah, well then I can just use, I guess, these here maybe. How much ohm was that? So these are 150. That means they drop even lower, 1.8 volts. What are you doing? This is a stupid calculator. clear the R field. Oh, okay. Well, 2.530. So if I would go, that's, what have I used? I have used 200 ohm. I guess that's why they are also so, I'm used to like the clear ones that are like a bit, I don't know. Yeah, I understood that it was focused on like on the, yeah, whatever. Let's see, what was this here? 120 ohms. So I guess we use these here, and maybe I replace these one up here too, because I think these were 220 volt, and they are quite dark in some way, compared especially to the blue LEDs. And maybe I want to put the blue LEDs even further down because they are so obnoxiously bright. Okay. The forward watches depends mainly on the color. Yep, yeah, I know. Crap, I forgot which ones were. So these one were the 120. Okay. So let's first replace here the LED. I want to see how bright those yellow ones get. Okay, Clipper, I know I hated on you earlier, but I need you now. Oh, there. So now the yellow one is a lot brighter than it was like before. It's definitely nicer. Let me replace the other two here as well. Take a pen, yeah, good. I should. Are you going to make a video about RAM bleed? I know you usually don't do videos on current ones, but this sounds pretty interesting to me. All these hardware vulnerabilities are super incredible, and I would love to make in principle, I would like to make videos about this. And I also would in principle like to make videos about current vulnerabilities. The problem is just a time issue, because usually I don't, like, when they come out, I don't have the time. And now specifically with like these things like RAM bleed or even Rowhammer in the past, or what's it called, Melter spec down stuff. The problem is I want to do these videos properly. I don't want to just make a news video just reiterating what people can read on the official website. If anything, I would want to read the paper and really understand it and reproduce it and show it off and show something, you know. And so that would require me to dive deeper into the paper and all that stuff. And I haven't done that for any of these vulnerabilities. They are super interesting to me, but I don't know, I haven't, like, other stuff has just had always priority over it. But I definitely want to make videos about these kind of things at some point. And then I also don't think necessarily that it has to be a current vuln. Like, just like the principle of these attacks. Like, even just replicating Rowhammer or something like this is it's just really cool. But yeah, like I said, I would want to understand it a bit better and make a nice technical video about it and not just a high level news video. Cool. Okay, so they are now a little bit brighter. And maybe we can place a 400 ohm for the blue ones here because they are so obnoxious. Oh, these were 150, then these were the 400. Yeah. Melter inspect. You're right. Wait, what? It's meltdown inspector. Clearly, I'm not qualified to make videos about them. Okay. Like that. Let's see. On the LED datasheet, there should be a graph with the LED luminosity depending on the current passing through. I never actually looked at something like that. Let's see. Oh, this datasheet is just 2 pages. There's no other one linked. Okay, let's see. Okay, they are clearly a bit darker for me, but on stream they look almost the same. It blows my mind that just a day ago I found your YouTube video about configuring a debugger for browser hacking, and not even a week later I bumped you into Twitch. Thanks so much for the great content. Thanks so much. How do you happen to stumble over this Twitch? Did you just see a tweet or some other reference somewhere else, or were you just literally browsing Twitch? Yeah, I'm really curious about that. Especially because I'm streaming in the just chatting section, deliberately trying to get people like to have like random people and not Discord server notification for me. What kind of Discord server? Okay, great. So we got this, and now we can do it here. Discord server. Let me see, just for like brightness reasons, I want to now see how with 100 things this looks like. Okay, so this is the red. It's pretty dark with 120. Oh, well, it looks nice. It's like not in your face shining. I mean, all of these stuff I can also change later if once we see the whole picture and we want to make them lighter or darker. Amazon is tracking my likes for sure. I watch a lot tech programming streams. This channel popped up in my recommended channels in the sidebar. Wow, that's interesting. I mean, I'm streaming and just chatting, but I did add the tags for like programming, web development, and stuff like that. So I guess that's how Twitch knew. But yeah, okay. So let me show you, or let me also check again. I want to see quickly a picture of the whole 8-bit computer. Oh, I need something to drink. It's just so warm. So today's mug features Madame Seuss. Wait, is that her name? Not Dr. Seuss. My God, not Madam. What am I talking about? Okay, Ben Eater. So here we see like the register, one of these registers, and he has his LEDs here, and he has a flag register on the right of it. He has another register, and he has stuff here on the right of it. He uses it like to have like wires here through. I don't, wait, he kind of got it to fit here. Let me see. They are just too, isn't it too tight, like right next to each other on, yeah, it's too tight, right? Yeah, you couldn't, how did he do that? Maybe I should have bought like 3mm LEDs and then you could have them here in a row there. But also he's not using any resistors on these here. I'm conflicted. You can even see a register value. Yeah, that's actually why we added a third chip here. Only or why Ben Eater added a third chip here. Only these two here are the actual registers, and this one is like a bus transceiver sender chip. But these ones don't show their value consistently at the output because they are also you can like turn the output on or off, and you don't want them to output all the time because you connect it to the bus and you don't want these chips to output their value on the bus all the time. You want to disable that. But when you disable that, then you can't see the LEDs anymore. That's why we basically added this like middle stage that these consistently output, but we have this bus transceiver here that will then actually handle if we output or not. So yeah, so these consistently output, and yeah. Wait, are you following a guide on this, or is this something you know how to do? Oh yeah, I'm following a guide. I have no damn clue what I'm doing here. This is the series by Ben Eater. You find it on his website, eater.net, or on YouTube. That's how I discovered this originally. He has here this whole playlist of building an 8-bit breadboard computer. And I always wanted to do that. So I'm just watching his videos and build it on stream. Many people have built and followed his guides and have made videos about it, and just this is my version of it. I also want to really want to build it, and I thought I could combine that with live streaming. That's kind of, I hope that's kind of fun to watch. So I'm learning here too. You know, I'm an amateur. I'm watching the videos. Sorry if that's disappointing, maybe. Okay, wait. So I'm conflicted. So what do I do now? God damn it. How much space kind of does he have there? So here's a marking. So here's a marking and here's a marking. That's roughly how wide it is to have these wires to go up there. I mean, there he also. Oh wait, I just realized there are 3 registers. This is the A register, the sum register, and the B register. At least on this version here. I mean, we are free to build however we wanted to. But all 3 registers have stuff on the right, and on the original A registers, there's here enough space. But on this register here, there's basically no real space. I mean, you could put it all the way to the right, then you have a bit more space, but also here are the cables. So, yeah, so I'm not sure. I can't show the link right now on this laptop because I don't have the chat open here, but I just clicked on it here on my other laptop. You should check it out. Oh my gosh, what a monster. Let me guess, is this a German person who made this one? Because you can't get these wires easily. Because Germans only work with these kind of jumper wires. Oh my gosh. A decision has to be made. I guess I go Ben Eater style and just plug it in down here. Look, I don't like how kind of. Can you see that on stream? That they look like this. Let me check. I think I still have small LEDs here. I have also red LEDs here. Let's see, small ones. So I would have enough for 1 register. But then they are like small LEDs compared to all the other LEDs that we have. Can somebody help me? I can't make a decision. Oh my gosh, this was a mistake. Okay, so what? Crap, I didn't even record what happened. I plugged in the red LED directly to the power rails because I thought, maybe they can handle it. And then they got very hot. Like very hot. You can still replace them later, I guess. Okay, do it like Ben do it. That's a good idea. You're right. Let's follow Ben's videos. And then later, when we get a better picture of everything, we always have the choice to then iterate on it and modify it and change this. And maybe we want to change the LEDs. Thank you. Fair you. Okay. Okay, so these are going into, I guess these are outputs from, so these, I guess we plug them into ground over here. Okay. Oh, so Ben either meant to somehow have another row of free slots here because we need to plug in on this rail here the positive of the LED, and there's like no space because I went up until here, and he saved that. He condensed these wires more to have space here for LEDs. How did he manage to do that? It's crazy. I guess let's try 3 wires per row. Like that. Then we can move, I guess this one can kind of stay there. But we move this one into here. I'm so happy that I finally have a chance to tune into your stream now that my exams are done. How many hours have you invested into the project now? Oh, cool. What kind of exam? Did it go well? We have only just started. It's a it's a 5th stream. What is the title of this here? Oh, it's still the wrong title. Thanks for the reminder. So it's just the 5th stream on this project. The 4 previous streams were over 2 to 3 hours. So I guess we are at like 12 hours or so with this project. Wow, that's kind of a lot already. And we basically didn't do anything. Well, things always take more time than you initially think it will. Hi, Sophie, man. Yeah, and today we are streaming for 45 minutes so far. Making the wires take the most time. Yeah. And we haven't even started with wiring stuff, and it already took us 12 hours. So be ready for a year-long journey. All right. So if we plug in this here, we can clip here, and we bend right here. Ah, crap. Well, here's the now if I start now here, it will slowly move further and further over there. Okay, wait, let's take that out for now, and let's first prepare a couple of LEDs before we plug them in. By bending this and cutting one side short, and then we can, I show you what I mean. Let me prepare this first. So 2, 1, 2, 3, 4, 5, 6, 7, 8. You need different wire stripper, the fast one. I think you weren't here earlier in the stream. Let me show you.
Or the output to the bus. And of course we've got the reset here as well, which is this pin.
Ah, wrong guess. Oh, pop out. Getting the lecturer to sub, nice. What do you mean? Okay, wait here. I hope. I have an announcement. Okay, wait. Okay, there we go. Okay, wait. So this was earlier in the stream. Everybody, pay attention. I have an announcement to make. Something incredible happened today. I was being let down by the delivery of tools that we need for the battle of the wires. So today, before the stream, I ventured out into the world, into the real world outside. I had to encounter people, other humans. I traveled in a carriage full of other humans. It was awful. I walked through the blazing sun to find the one tool that we need after being let down by the delivery people. But I couldn't wait any longer. So, here it is. Wire stripper. Finally, you can ditch the terrible clipper to strip the wires and destroy them. We have a wire stripper. This is gonna be amazing. Oh my gosh, I can't believe that I finally got it. I don't know if it is any good. It's not the one that I wanted to order online, but I think it will help us tremendously with the task that is ahead of the dozens and dozens of wires that we need to strip. I'm so happy. There we go. This was early in stream, in case you missed. So yeah, we got a wire stripper here. Wait, what was the thing behind the wire strip in the beginning? Oh, I was just like using like an LED light. I wanted to have like an effect of, you know, like an epic god light or something like this on the wire stripper. So it was like, it's the, so I don't know if you noticed, but back here there's like a little bit of a light here. It's because it's so dark back here, I use another LED light over there to shine in that corner, and that was the one that I used as like an effect. Light mode, yeah. Casuals with the wire cutter or wire stripper. Filthy casuals. By the way, if you joined a bit later, today's stream will be shorter. I have to really cut it at 2 hours because I will later go out and meet some people. And so I need to get ready and stuff like that. So I plan to have like 2 hours. So we are 50 minutes in now, so like a bit more than an hour. Alright, so now we can like plug them in nicely and then measure exactly how long the metal thing has to be. So I guess maybe like this. That's actually, it's almost too close together. I almost need like 3. Okay, so I guess we can actually do this further over here. Wait, or maybe here. we could also kind of like have a very small division to see like the individual nibbles. I don't know, the spacing is, oh no, I guess it looks fine. Maybe here it's a bit tight. If we put that there and this here. Yeah, it's like not possible to have perfect spacing, but I guess this is actually good enough. That's pretty okay, right? I don't know, it would be nicer if they are all like nicely touching, a bit more condensed, but it's either too much and they push each other out of the way, or it looks a bit like wider like this. But I think this is good, right? You could do the first LD pin on the begin on the wire on the side of the skip, then one. Wait, what? This looks good. I think not perfect spacing, but I think it's good enough. Okay, so this has to go over here, so we bend right here. This one goes here, so bend right here. How am I so bad at this? This was way too long. This one goes in here. And this one goes all the way over here. I mean, the wire have no hole, but on the beginning of the wire it has holes above. I mean, I can still like I'm not sure what you mean, because like if you have one hole in between, they are so tight that they kind of push against each other. Then they are like angled a bit outwards if they are too tight together. So like one hole in between, like these, or maybe, wait, maybe it could have worked. Like these two here are one hole apart, but they are like touching. So you could get like 3 per like of these 4, and then you have a wider one. I mean, right now I basically have 2 holes, right? And then we have like these gaps always in between. So we have like, here's a single one, then these 2 are 1 hole apart. Then we have a gap again. Then these are 2 holes apart. A gap again. These are 2 holes apart and a gap again. Oh wait, if this is a gap, 2 holes, gap, 2 holes, gap, then actually maybe I should also no, it's not quite that way. No, wait, well, it's fine. It's okay like this for now. So these go over here. And this one goes over here. Is it also warm wherever you guys live? Okay, the export. I really appreciate, but I really don't quite still understand it. Can you maybe like draw it in chat like this? Maybe do like here, I draw you. So there are 1, 2, 3, 4, 5. So maybe you can like put X's where you want the LED to be instead of the dot. 13 degrees in Belgium. Oh my god, let me check the temperature here. So in here it's 32 degrees, but outside it's 35. Is that correct? Or maybe my measurement is also in the sun right now, I'm not sure. What does the regular weather app say? Well, the regular weather app says 32 degrees, so yeah. I live in Germany. Yeah, well, you can see it. And like my apartment is really bad. We lost an LED. My apartment is really bad because we get our apartment is like around the corner of the building, and this corner is pointing directly south or wherever the sun is. Is the sun south? Ah, found it. And so we get sun all from the sun getting up until the sun goes down. The sun is just shining in our windows, which is nice, you know, daylight all day long, but it's so goddamn hot. And that's why we have we bought like these mobile AC units. They are inefficient and waste energy, but they make this place bearable in the summer. However, they are very loud, and so I don't want to run it while I'm streaming. There we go. Looks all right. Okay, I guess we can continue with the next video, I think, where we test if this thing that we built works, because I don't know if that works yet. Okay. You guys have bearable temperatures. I'm so jealous. Just buy a big ice cube from Norway and put it in your room. Bonus fresh water when it slowly melts. Transport logistics is just some paperwork. Do you got a company you can recommend? Okay, let's watch this video here.
So our register has all these connections, and so in order to test it, we've got to connect some stuff up to it and kind of play with it and see if it behaves the way that we think it will. So what I'm going to do is I'm going to use another breadboard just with 8 LEDs on it and use this to kind of see what our bus is doing. So what I'll do is I'll hook the bus connections up to these LEDs. And of course we want to make sure they're connected up in order. And so now our 8 bus connections are connected up to these 8 LEDs, and they're connected in order here, so we can see what our bus is doing. And of course we also want to connect the ground of these LEDs over to our board here, so we have a common ground so that our LEDs will work. And so now we should be able to power this up and see what it does. So I'll connect our power in here, and it looks like everything is all zeros, which is, I don't know, maybe interesting. You know, these are D flip-flops here, so they could start in either state. So some of yours might start on, might start off. We don't know. I'll set the enable to high, and I'll set the load as high as well, because you know, these are these sort of inverse signals. Remember, so they're inverted. So you know, setting enable to high means we're not enabled, and setting load high means we're not loading. And then we'll bring them low to actually turn those signals on. And then the last thing we have is our clock here, and I'm going to hook that up to our clock circuit that we built in the previous video. So we'll just hook the clock up just like that. And then I also want to hook the power connections from our clock up to this board. So we're powering our clock. And there we go. Now our clock is flashing away there. And so now we can start to test this. And so the first thing I'm going to do is I'm going to see what happens when we bring our load pin from high to low. So in other words, we're telling our...
Actually, maybe we kind of pause, because now he's testing. We could now test with him in the video. So let me also get this set up. I have to answer some of the questions. What ThinkPad are you using? This is a T450S. Yeah, I didn't. I got that from a competition. I didn't chose this for any particular reason. How many breadboards will you need to accomplish this? Somebody wrote 12 breadboards, but I think the original part list was 14 breadboards, but I ordered 16. So I have this whole pack of breadboards. Yeah, the whole thing, depending on where you buy the parts, how expensive your breadboards are and stuff like this, obviously varies the price. But yeah, $250. I think I paid $240 for my initial delivery now, but I will probably reorder a couple of parts again. It also helps if you already have a little bit of electronic stuff at home, because you might need like an oscilloscope, you might need like a power source or something like that as well. So if you bootstrap from zero, it might be a little bit more difficult. But yeah, exactly. I don't think that the price is too terrible, especially for the learning experience that it provides. This is like Lego. I love Lego. Lego is a great entertainment and a great toy to play with. So just imagine this to be a big, more expensive Lego package, but instead of like offering you 8 hours or 10 hours of building fun, it offers you weeks of building fun. So it's like grown-up Legos. If you order the breadboards from China, you might get, yeah, exactly. The breadboards can get very cheap. Small warning, I heard, I don't know myself. Somebody said that in another video I watched, that breadboards can vary from quality, and sometimes these metal connections are not perfect. So you might have a bug, something is not working, and it's just because of a dodgy like line or metal in these breadboards. And apparently the ones that Ben Eder was using were good quality ones that should be fine. So they were, I guess, a little bit more expensive, but I think it's still fine. So then there was a question about the speed. So we measured it in a previous stream. The speed that this currently runs at is maximum 500 hertz, but I don't know how fast the whole CPU circuit later can handle. That's definitely something that we can experiment with once we build the CPU, how high we can go before we see glitches. That would be kind of fun. The power draw is actually quite an interesting topic, because Ben Eder is using these TTL chips, this LS series, and they constantly draw current, and so has a fairly high power consumption. But I also saw in another video of somebody building their version, and they figured out that there is an alternative CMOS implementation of these chips that are actually that operate on the same voltage like thresholds, and so they are meant to be basically completely replaceable to these TTL ones, and the CMOS ones they only consume when they are switching, instead of constantly drawing some current. At least that's my understanding of what I've heard. Maybe I misinterpreted it or something like this. So that person mentioned that they were drawing also a bit less. The power consumption apparently is also generally a concern. This person that was saying that saw that throughout this whole circuit, current was kind of dropping, because you connect all these breadboards together, and so you always have these metal wires plugging into the metal slates of these things, so they just have like contact like this, so they are not perfectly nicely connected, and so apparently you can lose quite some voltage over the whole thing, or like whatever. Or is that what you lose? I don't know, but so that means that later some components later in the circuit had problems. There was the voltage already too low, basically. So there are quite a few things maybe you need to think about at some point. So I'm not sure. He measures the amps when building, because every breadboard will draw power, and I think LED boards will draw the most when LEDs are bright. Uh, there was just many sense. Yes, you have to wire the plus and minus from starter point to our boards and not from board to board. Yeah, so these are the things. We will stumble over them. We will see what happens. All right, okay, so let me plug this in. So I guess these are all just going to the same connections of this blue one here, I guess. The second breadboard is here. Yeah, from each power supply to each board. Yeah, I understood. Okay, so is he always running these LEDs without any like resistors, just like directly? It's so weird. Or can why can these LEDs handle this? Okay, I definitely need to order some more LEDs from these yellow ones. I only have this many left. Why did I order so few? 2, 4, 5, 6, 7, 8. And so this is connected to, he connected to ground. These can handle it, but they draw way more power if you don't have the resistor. Well, I plugged in that one 3mm red one earlier, you know, the clear one. This one directly in the power rail to test how bright they are, and it got so hot I couldn't hold it anymore. But maybe these clear ones are also like more high power or something like this. I don't know. So maybe they, I don't know what I'm talking about, but maybe there's a difference between these ones and obviously I also can't count because these are 7. Okay, then we need to connect the ground rail. Directly into the power rail. I assume the current limit of your power supply saves the LED. No, it didn't click. I'm pretty sure I tried this before. The LED will shine bright for like a couple of seconds and then burn out. use 1 on the ground line, not 8 times or just before the test line. But Ben Eater didn't add any resistor there for the LEDs. Should I add one just to... Yeah, maybe that's just not needed. Why is this not needed? Why don't... Well, I will hold them in a second when I plug them in and see if they get hot or something. We will see. Okay, and then we need to connect here. This is like the enable or the output enable or something like this. We go from plus to... Crap, I think that must... Yeah, the second pin. What is it? The 17th pin or something. And then we have... Over here we also need to connect... this here to ground. What was that again? Let's look that up in a second. No, that was VCC, and this ground, we are grounding here the second one. Okay, let's quickly, I want to quickly check the data sheet again, what we plugged in there. What is the ref of the ICs? Yeah, okay, that's the output of these. Oh yeah, I think Ben Eater mentioned something like this last video, that these ICs already have a resistor for the output on there, or something like this, if I remember correctly. But yeah, maybe the ICs are already limiting enough that it doesn't burn out. So we plug that into, so 19. Okay, so yeah, so 19 was put to VCC, that's correct. And down here we connected 1, 2, 3, 4, 5, 6, 7, 8. We connected pin 9. Where's pin 9? Connected 9 is the AI. What is that? Blah blah blah. So 9 and 10 are connected. That is correct. And they have a connection to AI, and we put that to VCC. So we need to check out again what these ports were, what AI is. And I guess the other one was clear. So 15 was clear. So yeah, this is 15. That is clear. Okay, so this... Does anybody remember what crap, sorry, I didn't show it on the big screen. What this input here, AI, is probably some kind of enable or... Oh, in or out. If you want to read in, you deal with that. And if you want to enable the output, you do... So, yeah, you enable them reading or setting the values of these registers with the input, and you decide if you want the output onto the bus with O. Okay, I think I feel kind of confident to almost plug this in. What else do we need? We need to connect the... We need to connect this to the clock output. Let's also turn this around. Let's plug this out. Put that in the top here. And we put this into the... This is the clock here. And we take that... So this is the clock input down here. And then we connect the ground here. Okay, moment of truth. Okay, no short circuit at least. Nothing has blown up. The ICs don't feel hot. Oh, wait. Like this. Okay. Connected the clock and the power here. All good. Okay, so now we can continue watching the video.
Our register to go ahead and load whatever's on the bus. And now there's nothing connected to the bus, and so it'll be sort of interesting to see what happens here. So if we bring that low, we see that when the next time the clock went high.
Hi Procker, and it's all good, don't worry. I'm really grateful for the subs you already gifted. Please don't feel obliged to do anything more. Thanks so much. You are not being forgotten. You don't need to keep doing that.
Everything, all of our
Wait,
of our
what
bits
did he
in our
do? I
register
didn't
went
pay
high.
attention.
And you might wonder, next time the clock, when we bring our load pin from high to low. So in other words, we're telling our register to go ahead and load whatever's on the bus. And now there's nothing connected to the bus, and so it'll be sort of interesting to see what happens here. So if we bring that low.
Okay, let's do the same thing.
We see that when the next time the clock went high, everything, all of our bits in our register went high. And you might wonder, well, why is that happening?
It's not happening for me. Okay. All of these chips have ground connected for sure, and VCC connected. The blue LEDs are the clock. So this left one is the actual clock, and the one on the right is the inverted clock. So that's why they are always alternating. So basically this is our clock, and this is just the inverted clock. So we connected here now the clock output. Oh, wait. I didn't connect the clock. I connect the clock after the resistor. Yeah, still didn't do anything. Oh wait, now I need to put it. Okay, still nothing. Thanks, Procker, for the gifted sub. Rewind video and do steps again, yeah. Control C, Control C.
Is I'm going to see what happens when we bring our then the last thing we have is our clock here, and I'm going to hook that up to our clock circuit that we built in the previous video. So we'll just hook the clock up just like that, and then I also want to hook the power connections.
Let me also move the power up here, just in case that this was already too far away. Nope.
From our clock up to this board, so we're powering our clock. And there we go. Now our clock is flashing away there. And so now we can start to test this. And so the first thing I'm going to do is I'm going to see what happens when we bring our...
The bus is flying, so any output should be possible. That is true. However, Ben Eater... Okay, maybe I shouldn't have interrupted the video. He was like leading on. Now everything is high. Now why is that? And so I assume what followed is him explaining why in the current version how it is set up, it would turn to high, which we didn't see. So let's see.
Our load pin from high to low. So in other words, we're telling our register to go ahead and load whatever's on the bus. And now there's nothing connected to the bus, and so it'll be sort of interesting to see what happens here. So if we bring that low, we see that when the next time the clock went high, everything, all of our bits in our register went high. And you might wonder, well, why is that happening? There's nothing on our bus. These are all off. Why would these come on? Well, because there's nothing on the bus at all. These pins aren't high or low. There's nothing driving our bus. There's no inputs here. This is the registers are going to default. Any TTL chip typically will default to a high input. If you don't connect the input, it defaults to high because there's typically a pull-up resistor inside the chip there on the input. And so that's just what we're seeing. We're seeing that since there's nothing connected, they just show up as high. But what we can do is we can now take our load pin and bring that high again, which turns the load off. And now we can take our enable and see what happens when we enable this by bringing enable from high to low. And we see when we bring that low, we see the output. So we have all ones stored in our register, and when we enable the register, we can see that enabling it outputs the contents of the register to the bus, which is exactly what we want the enable to do. Now we can try something else. We can try inputting a value, and the way we can do that is, we saw that by default we're getting ones. So what we could do is we could just connect some of these bits here to ground, and that'll, I don't know, connect these bits here, and maybe we'll do one more. We just connect this bit over here to ground. And now if we try to load what's on the bus, we should see 3 of these turn off, and indeed we do. And so now we have that value on the bus. And so now if we change that value, so these aren't, oh, whoops, we're still loading. That's why, yeah. So we're still loading. So it pulled in that new value when I disconnected these. So let me reconnect these. Normally the load would only be active for.
You can troubleshoot with your oscilloscope. All boards are high there. I smoke weed to translate these videos. Okay, so I thought maybe we could check really quick if all the chips have actually, if all the chips actually do get, then connect some high and some low. Yeah, true. Okay, wait, let's do this first. Let's see what happens if I would actively put one to plus. So I connected it here. So we need the input. Wait. Something is wrong already because I connected this board. Wait, this board has no VCC connection. Ooh, okay, because the LED should turn on. And it didn't. So let's connect. I thought of course I didn't need VCC for the LEDs before, but now if we want to test that. Okay, so this LED is now on. Okay. Wait, so what was the direction? I forgot. We need to look into the data sheet again. So this is the read. So this is input enabled is negated. This means if it's to ground, then it should read in. But it doesn't. Okay, so let's measure just a few of these. The LED looks on. You are right, it's kind of dark. Okay, let's measure quickly the voltage on this LED here. Oh, there it reaches 4.2 volts. It's not affected by the other connection here. Wait, maybe these LEDs are glowing. They are just like super dark. If that one with 5 volt or with 4.5 volt is already so. These ones here are slightly glowing. Do you see that? The current limit. There is a current limit, but it doesn't seem to affect this. However, I'm not sure, you probably don't notice this on stream. Maybe you even notice. Do you notice how it's affected by the clock? How bright it goes? This is fun. There's like something completely wrong here. So this here is the output enable. If the output enable is also negated, so plus means it's outputting. Okay, so output, oh, did you notice this? If I disable the output, it's not outputting anything. So if I put it to minus, no output. If I put it to plus, or even just disconnected, then I see them glowing. That one LED that I had directly connected to plus 5 volt is extremely hot. Ow. Are they blinking on the clock? Is the bus driver correctly connected? So this one here, that is the output. I feel like that one should be kind of fine because it does, I don't know. Okay, wait. So now let's see what arrives here with these faintly glowing LEDs. So we are here at 1.7 volt is coming out. And if I disable the output, then it's 0.8 volt. Let's see. Let's measure really quick the clock. I need to slow down the clock more to measure it. So the clock that we get here. I need to put this to ground somewhere. So the clock we are getting is 3 volt. I mean, my thing is, wait, let's go to manual clock. So this is the 0 clock, and this is the on clock with the 3. Maybe you're right with the LEDs. Let me disconnect this LED and this LED. Wow! Yeah, now it's a lot higher. Okay, so that's Okay, so the clock that is arriving here has now 4.2 volt. And the clock that is then passed on to the other chip is still 4.2. Okay. I have a resistor for that LED. The blue LED up here has a resistor here. So it was coming out here. This is where I took the value. And then that was going into a resistor. that is here. I can't lift it so well, but here, this resistor here, so here's the output for the clock out of this chip, and then there was a resistor going into the LED, but there was still bigger resistor. We even increased the resistor earlier. But okay. Okay, but now there's no resistor, so it should be. So now, I mean, now we measure here 4 point thing. Okay, so let me quickly check the power that is getting to each chip. I think each chip has like VCC on 1, and then GND is not shown. Here. Sometimes the CISA are accidentally powered by just connecting one data pin to VCC and one to GND. Yeah, that makes sense if they are internally somehow connected. So ground was on here on pin 8 and VCC on pin 16. So on these one here. So 8 is ground. I guess if I should put here and here I should measure like a difference. Only 4 volt arrive here. Maybe I should turn up the voltage a little bit also on my because I dropped under 5 volt under load here on this. Now I don't know anymore. Okay, so blue LED again. Let's see. Yeah, with the LED it only goes up to 3.3 volt. Oh man, electronics, I'm already like... Yes, and it looks like it's powered but works so too much voltage drop over the boards. Okay, so this board, so right here when the wires are coming in, I'm measuring 4.9 on this board. I'm also measuring 4.9 still here, and on this board then 4.9. But see how it crazy it dropped? It was 4.98, then here it was 4.95, and then over here it's 4.99. Put the input current to the other board. Okay, let's put it over here. I short circuit them. Good job. This one I think is darker than it was before. This is crazy. Anyway, so this is I guess our test LED. Let me check what. So the clock should be pulsing right now. Yeah. Okay. Okay, so wait. If the, I just noticed that the LEDs, let's see. If the, so if the input is enabled, so it's reading, versus out, versus disabled. So if it, I only see these LEDs on when the registers are input enabled. If the input is not enabled, like this. Now, this is also because the output right now here is, but the output is also enabled by GND, but right now it's on VCC. Oh, that's because it's disconnected and floating right now like this. So minus is, now it should, we should see output. And now everything is dark. Oh my god. Put the test LED. Put the test LED on one of the red LEDs. You mean like use a red LED for the clock, or did I misunderstand? So let's measure again our clock strength. Also 3.2 now. Maybe, so if this chip can't like fully drive it, maybe the, it doesn't, it's not properly powered. Though all of these look properly connected. Okay, let's measure the power connection on all of the chips really quick. If you connect the two grounds in on the middle board, connected the two grounds, they are on this side. So they should be pin like 8 or something on these ones, on the registers. So yeah, pin 8 is, sorry. So pin 8 is GND. On the registers, it's bottom left, and you see here a, oh my god! The same mistake. We did this. I did the same mistake already before. The same mistake. Thanks, Moocher. The same mistake. I forgot this with the other board too. I need to connect the other rail. Look at this. Now they are shining. Now, okay, so output is right now enabled and reading is enabled. So let's okay, so let's disable the clock for a moment. So let me think. We watch Ben Eder's video in a second again. Put the blue LED for the clock. Yeah, I'm curious too. You're right. So Okay, so clock and everything is connected. So let's see. Let me think. Let's go to the other schematic here again. Wrong button. I guess I can't make it bigger. Okay, so wait. How is it supposed to work? We enable the input. And when the clock comes, it should be stored. So these LEDs are also not working right now, right? That makes total sense because I connected them wrong. I connected them all to VCC and they need to be connected to ground. Oh, okay, wait. Now I'm clashing a bit with the other wires and the thing is a bit too long and stuff like this, so now it's not as pretty anymore. But we have kind of committed to redo this anyway at some point, right? So for now, it's fine. Okay. Now they are also glowing and are on. Okay, so now let's think. We enable the input. We pulse an LED. Oh, wait. That cable is, I guess, a bit dodgy here. Okay, that's just a dodgy cable, or the connection or something like. Maybe let me replace that cable. Don't have a blue one anymore. Okay, oops. Oh, sorry, there was a auto-moderated things. By the way, just to boost my ego, the problem was discovered via a Pixel 2 screen I have about window to look at cables. Nice, amazing. Well, that just is evidence of a very smart mind. I asked this before. Sorry that I kind of missed that. It's the second time I make this mistake. I absolutely know that they are not connected, but for whatever reason it didn't like click. Love when I have to reread a message. So this one was because of make out. So making out, I guess, is an rip cam focus. Yeah, I'm really sorry. Wait, okay, let me disable autofocus. Somebody already, maybe it was even you, complained about it yesterday. Properties, configure video. Oh, I can't. I seem to not be able to change the autofocus from in here right now. Okay, I need to deal with it later. Okay, so now we pull one to ground. Now it's off. And now with the next clock, it should read that in as the input. It did it. It read it. Turned off. Then we disable the input again. And this is the output that just shows whatever is stored in here. So we can, yeah. So some of the LEDs look brighter just because of the angle and stuff, but they are all like the same brightness. It's just the angle of the light. And so this one here is off. That is what is remembered. And we can either make it like output or disable output. Enable output or disable output. So let's try to turn, let's turn that LED on again. Oh my gosh. I did a short circuit. Did you hear it clicking? Oh fuck. Oh, that chip got hot. That chip got hot. Yeah, let me put the current limiter again to values that just are barely making it. Oh god. I just want to say watch out. I'm sorry. Oh goddamn, hopefully I didn't fry it. It's still hot. It doesn't smell like magic. It doesn't smell like magic smoke yet though. It's still super hot. Why is it so hot? Maybe it's just because it has to drive all these LEDs. Maybe that's just the state of it. It doesn't seem good. Oh my gosh, it's really hot. Because you also think of the LEDs? Okay, let's disconnect a couple of the LEDs. The LEDs are warm, by the way, too. This doesn't seem healthy at all. Let's just keep one LED for now. And let's wait until this chip cools down. And then let's try this again. And then I'm also at almost 2 hours. I need to stop after we did this test with the single LED. But the other two chips that are driving these LEDs, they are not hot. Oh, the Norwegian Ice Cube. Yeah, I asked for a good recommendation where to order it from, but I didn't hear anything. You would stop 20 minutes ago? What do you mean? Can you test if it is fried? I guess the test if it's fried is if it still functions as it should function or not. Now this just makes testing worse because we were not even sure if like it works all properly. Okay, so it now cooled off again. So let's turn it back on. The output right now is disabled, even though like in the registers we have stored all highs. So it's not warming up. Okay, so now let's enable the output. Oh wait, oh yeah, input is disabled. Oh, maybe it also got hot because I had the input and the output enabled at the same time. I think that's something you shouldn't do. Ben doesn't add resistors to his design because they are internal resistors, but adding them to all LEDs is a safe way of doing it. Yeah, I remember, you're right. I think I remember him mentioning that in one of the previous videos where he showed like the internal resistor. Okay. Still not getting hot. Okay, so input is disabled now. Now we output. And we see the LED. Now let's see if it gets hot. Seems all fine. Let's disable the output. Let's set this to ground. Let's enable the input. And then we give a clock pulse. See? Did you see this? We did a one clock pulse, and now the register read the value only when we did the clock pulse. See if I unplug this again. Clock pulse. Turns on. It reads it. Now we put a 0 on the bus. That's our bus. And when we get the clock, now the registers read it. Awesome. Now we disable again the input, so now it's not reading anymore from the bus. So even though we have like clock, so if this is disconnected, there's a 1 now on the bus, but as far as we have learned, and now reading and executing the clock, nothing changes here. It stays off because reading is disabled. And then now we enable the output onto the bus, and now it should stay off. Perfect. We disable the output, we enable the input, nothing is connected, so there's a 1. We give 1 pulse of the clock, it's reading it, it's a 1 again now. We disable the input, we enable the output, there's a 1. So at least that one register bit works. And the chip is maybe is a bit warm, I would say. Actually, I kind of want to buy a FLIR camera to like show the heat of the whole place. That would be also good for debugging. We would see if a chip would get hot. I always wanted to buy one, but they were too expensive to just as a joke for fun. But maybe I can justify it now. And when you short it, the whole thing just gets red. Yeah. Oh, that would be kind of cool to have a FLIR camera. Okay, we'll look into. Has anybody experienced with? Has anybody had like an affordable one? I know that there are, for example, attachments to the iPhone. Maybe that's my cheapest option, to have it as an attachment to the iPhone or something like this. I want to research this. That would be kind of cool actually, to have like a heating camera here as well. I have cheap ones now, laser temperature at dollar stores. What do you mean laser? But that's a laser temperature measurement. I mean like a FLIR camera, you know, that shows like a heat map of whatever it's recording. You could use isopropanol alcohol to speed up evaporation. Poor man's heat. You know, I mean, what do I do with my incredible YouTube wealth? What else should I spend my money on if not a heat camera? Okay, so I would say I quickly connect the LEDs again just to test all registers one time with like reading and writing, and then that's the end of the stream. Okay. All of them are glowing. Great. So we disable the output. I was more thinking of a digital oscilloscope and then have an overlay on the stream driven by the effects on the register LEDs. So an input, you mean like a digital oscilloscope with 8 inputs? I mean, I do have like a logic analyzer with, I think, 8 inputs. Yeah, I'm doing that. I did some. Oh, you have a YouTube channel? You want to link it or something? Okay. So it's getting not hot right now. Okay, so we disabled the output. Input is also disabled. Let's take it back to the regular clock so we don't have to click it ourselves. And then we can slowly minus. Okay. Wait. Oh, input. We need to enable the input. Okay. We are reading the 0. We are reading the 1. Always on the clock pulse. Do you see this? So I try to first connect it, and I say when I connect it, and then we need to wait until it turns on for it to actually read it. Sorry, I didn't say it. I'm stupid. Now. There it is. Okay, so this one seems to work. This one works. 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 Oh wait, there's something wrong. 3, 2, 1. Wait, 2, 4, 5, 6, 7. Did anybody notice that I don't have 8 LEDs here? I missed to plug in one. So this one is also working, and this one is also working. Cool. The register works. I reprogrammed my logic analyzer back when we had to show how to use them. So instead of the normal GUI, I had made a program to control it for the test. They had to let me go after 3 minutes. What? Okay, cool. So this register works. We are past the 2-hour limit. I need to leave now and get ready. Any remaining questions? Anything else you want to say before I wind down the stream? Anybody online that we could host? Anybody a recommendation for a host? Did I really miss most of the stream again? Oh, hi Nuflo, I'm sorry. I'm located in Germany. Yeah, so it was a 2-hour stream, a bit short stream today. But we got a wire cutter now. A wire stripper, I mean. And we didn't get to use it at all. I just realized. I was going to the store specifically for this. And I realized we didn't even use it today. Thanks for the tip, Toby. Oh, that's a start. Here's a start for the thermographic camera. Thanks. And now I feel obligated to buy one. Thank you very much, Toby. Did you receive my email, by the way? As we had to show how to measure different stuff, I just hard-coded all settings and load them as they are, so I didn't have to touch any dials. Now they let you go because you succeeded with your when you had to show it to them. Oh, you sent me a response. Sorry, didn't see it. Okay, cool. All right. Thanks everyone for hanging out. Right, we need to find a stream to host. Like I said, does anybody know is following any other channels that are online right now? Maybe somebody in the science and technology category. I'm quickly searching here on my other screen. I'm not sure. I don't know many. Is there a rocket launch happening right now? Falcon 9. You just got in. Yeah, sorry. Short stream today because I gotta go. Let's see. Nobody any recommendation for a host? In science and technology are quite a few cannabis growing streams. That's interesting. Okay, then enjoy whatever you are doing with your mates. Thanks. There's a guy fixing cars. Demon machine. Do we really want to talk to somebody who is like doing actual hands stuff? You could raid Jay Hovgaard. He's doing web development right now. Vegetag Tatsi. Okay. Sorry, I just want to quickly check this Veget was mentioned first, so I need to, I don't know, I need to start following people. Yeah, that looks like good nerdy program. Oh no, Vegetax is doing blockchain stuff. Do we really wanna support blockchain development? Oh well, whatever. Where's my chat? But you can stream on YouTube and Twitch at the same time. That is theoretically true. 2 reasons why I don't do it. The first reason is that I feel like this has nothing to do. Oh, sorry, I don't have my camera. What I'm doing here is electronic stuff. It has nothing to do with my YouTube channel directly, so I don't want to annoy people. I think people have certain expectations about my videos and the content on the channel, so I decided to not stream it there. And the second reason is that while right now I'm a Twitch affiliate, I'm not sure about the rules about Twitch affiliate. Maybe it would allow me to double stream the same time, but definitely not as Twitch partner. You are not allowed to stream on other sites in parallel. So because I guess eventually I hope to be able to get Twitch partner. It would kind of suck if I get people used to streams on YouTube and suddenly stop and stuff like this. So let's keep streaming on Twitch, I would say. But I could stream on Random Overflow, that's true. Breadboard computer. Oh, it's Soding. When are you going live? Or are you live, right? You are not live if you're in the chat, obviously. No, if you are affiliate, you are also not allowed to restream. Well, okay. There we have the perfect reason. We also have exclusive content rules. Okay. All right. Well, then that decides it. You go live in an hour. Damn it. Okay. I'm really sorry. I wish I could stay on longer for an hour and then host you then. But I really gotta go. So let's host this blockchain person. And yeah, thanks so much for hanging out with me. We didn't build any more modules, but we did verify that the register works, and we didn't blow up anything yet. Almost though. And it was a good debugging learning experience. I think we still made good progress. And we of course got the holy wire stripper now as well. Okay, thanks so much for hanging out with me. Thanks for the bits and for the subscriptions. And see you probably tomorrow. Probably again later in the day tomorrow. Bye-bye.